Fellow rebels, it's Colonel Q here. We don't have much time. I'm in possession of the mysterious cosine law, and we have to learn how to use it to exploit the death try's weaknesses. See, the death try wants to stop us from solving all triangles, but with the cosine law, we can stop it, and we can take them down. First, let's go over why the cosine law is useful, and how it can help us, and why our other weapons, such as the sine law and SOHCAHTOA, won't apply here. The unsolvables, led by Kilo Theta, they've presented an example such as this one. Their goal is to stop us from being able to solve such a problem. See here in this triangle, we're given this angle, and we know sides 3 and 10. The problem is we now need to find side x. With our previous tools, we have some problems. First off, this is not a right triangle. There's no 90 degree, so we can't use SOHCAHTOA. It just won't work. Second, you're thinking, maybe we could use the sine law. The problem is we only have one angle. And the sine law only works if you have two sides given and one angle, or if you have one side and two angles are given. But thankfully, the cosine law, which I have stolen and I need you to learn, can help us. Once again, example 1 does not have a 90 degree angle. If it did, like the following triangle, we could use trig ratios and SOHCAHTOA to solve for unknowns. And again, for the sine law, if you'll recall, you need an angle who also has his corresponding side. So if we look at the angle of 60 degrees, we don't have his corresponding side. It's unknown, it's x. Also, if you try and take side 3, he has no corresponding angle, and side 10 has no corresponding angle. You can only use the sine law when you have that corresponding side and angle, such as in this example here. So here, we know the angle of 20 degrees with side 10. Then we know the angle of 115 degrees and side A. So we could use the sine law to find side A in that triangle. That's not the case. We need a new law, and that law is the cosine law. The cosine law works as follows. For triangle with angles A, B, C at vertices A, B, and C, first off, recall the following. If you have vertex A with angle A here, this is little side A, which is across from it or opposite it. And for angle B, opposite that would be side B, and across from angle C or vertex C, you have little side C. So we use uppercase for angles and vertices and lowercase for sides. Let's say you want to find a relationship based off side A. Here's the cosine law for that. So you take this side and you square it, and it relates to the other two sides like this. Okay, so that reads a squared is equal to b squared plus c squared minus 2 times b times c times cosine of a. All right, you can also work out the formula if you're after side b and side c. So I'm just going to pause, write those out, and get you to copy them down. All right, here they are. So if ever you're looking to get side b, here it equals the following: a squared plus c squared minus 2a times c times cos b. And the same goes for if ever you're trying to find side c, you do a squared plus b squared minus 2ab times cos c. Okay? At the end, let's say you want to find a squared. Well, you won't be interested in a squared, so at the end of your calculation, you'll have to do a square root to get a alone and not squared. And the same would go for b squared and c squared. Okay, so this looks like it's tricky to memorize and a lot, but let me show you with a few examples just how simple it can be to use the cosine law. Well, example 1 is going to look back at the original problem, so copy it down, pause the video obviously, and come back when you're ready. Okay, so I've just overlaid the note from before where I showed you the cosine laws, and you see there's 3 of them. Here's why. We want to find side x in that triangle, and you're thinking there's 3 formulas to choose from, but really there's only one. Okay, so let me show you how this works. I'm going to choose this formula and show you how you can almost disregard these letters and essentially customize the cosine law for each question. So let me show you how I do that. First, I'm going to write out the cosine law, the very first one we had for a. So a squared equals b squared plus c squared minus 2ab cosine of a. Now you're going to have to memorize one of these formulas. Okay? And in fact, if you have memorized one, you really can memorize all 3. But work on memorizing this formula here. And let me show you how you replace. So in this triangle, there is no a, there is no b, and there is no c. And I'd rather you not think of where should I put a, b, or c. I'd rather you think of the problem this way. So a squared here, that side there is the side you want to find. And that side you want to find, for our triangle, would happen to be x. So a in this triangle is x, and we need to square it. Okay? Then the other important thing to do, the next step, the angle that's basically corresponding with x is capital A. So this here, that's x, he corresponds with 60 degrees. So you know you're taking the cosine over here of 60 degrees. Okay? Then you're missing b squared plus c squared minus 2 times a times b. That's really easy to do because you always look for, there's the side I want, there's this corresponding angle. The other players, side 3 and side 10, they almost like sandwich the 60 degree angle. Okay? They make like this here. So they're sort of like squeezing the angle of 60 degrees. These sides squeeze the angle of 60 degrees. Well, those sides doing that are B and C. And it won't matter which one you say is B and which one you say is C. Okay? Here's why. All you need to do is 3 squared plus 10 squared. Does it really matter if you write 10 squared plus 3 squared? That won't matter. And the other thing, now you'll do minus 2 times 3 times 10. And does it really matter if you do 2 times 3 times 10 or 2 times 10 times 3? The order will not matter. Okay? So you just have to identify this thing's this way, and everything's going to work out. Okay? Now you need to do the math. So here we go. X squared equals 9 plus 100. Okay? Then minus 2 times 3 times 10. So that's minus 60 times the cosine of 60 degrees. Okay, Rebels, grab your FX991 MS calculator or equivalent, and you can do this in one shot. Alright, so the math says we have to do 9 plus 100 minus 60 cos 60 degrees. Here you go, 9 plus 100 minus 60 times cosine 60. It can happen in one take here, and then you get 79. So x squared equals 79. Now I realize you could also, if you have a different calculator, you could say that's 109. Then I'd probably like you to do cos 60, okay, which is 0.5. So this is 0.5. Okay, and then you'd have to do minus 60 times that. So anyhow, if you're doing it in parts, the parts you'd do would be 9 plus 100 minus 60 times 0.5. And you see how that's more work? It still gets the job done, and I realize not all your calculators can do it in one shot, but now you've seen both ways. Okay, so 9 plus 100 is 109. 109 take away half of 60, that would be take away 30, and that would still give us the same answer. X squared is 79. And as I mentioned a few minutes earlier in the video, now you need to take the square root. Okay, so you have the option of showing this with the square root here, and I'll show you after how you can just jump to the answer. And then the square root of 79, okay, is roughly equal to 8.9 units. And we found the missing side in the triangle in question. All right, Rebels, example 2 has another question where we must use the cosine law. This is not a 90-degree triangle, and sine law will fail us. We have no corresponding pairs. We don't know x, and we only know 35. 8 has no angle, and 11 has no angle. So you need to write out your cosine law, and let's go to it this way though. Okay, cosine law says, well, the side I want to find, I square it. Okay, so I want to find side x, and then you'll be taking the cosine of his corresponding angle if you happen to have the two sides that sandwich that angle, and we do. Look for that sandwiching of the angle. It's almost like the angle's sandwiched, okay, by 8 and 11, and you're off to go and get x opposite that. So now that we have that, we can say that 35 is our angle we're going to cos, so it's one of the last steps. So over here I'll be writing cos 35 degrees. Okay? And then it's completely arbitrary what you do. Whether you start with 8 and 11, okay, it doesn't matter. So you just have to follow the pattern of the formula. So I'm just going to write the formulas down. You don't really need to, but I still will since we're new to this. A squared, so there's our A, equals B squared plus C squared minus 2AB cos. And then if I use little a, this would be capital A. Okay? So I'm trying to say is you just need to write down the unknown here, the unknown side, and then realize you have his corresponding angle, and then look for the sandwiching. Okay, 8 and 11 are sandwiching that angle. Then they go in any way you want, and I just sort of go left to right. So there's 8. So we'll go 8 can be my B, which makes 11 my C. And, okay. Notice I made a little mistake in the formula. This should have been 2BC. But that's why I say the formula doesn't really matter. It's the understanding of how the numbers go into it. Okay. If you're off to find x squared, you need to find the cosine of his angle, and then the other two sides have to go in correctly. So 8 squared and 11 squared, the first thing you do to them, then you have to do 2 times 8 times 11, okay, and that multiplies cosine 35. Okay, so it's really important to see that pattern. If you're trying to find side x and you have the angle that is opposite that, and you have the two sides that sandwich it, it's easy to set up. Put the side here, put his corresponding angle over here, then the sides, well, go in order. 8 squared plus 11 squared, then you do minus 2 times 8, then times 11, cos 35. You're ready to grab your calculator, and you can actually do this in basically one shot. So here we go again. 8 squared plus 11 squared minus 2 times 8 times 11 times cos 35, and you end up getting 40.8 if we round to one decimal. Okay, so x squared equals 40.8. Then you just need to square root that, and again, I said in the earlier example we would skip showing that because we know to get from x squared down to x you would have to square root, which means you're square rooting 40.8. Okay, so I'm just going to hit my square root button, and I get 6.38. Why don't I go to one decimal place? And I get 6.4 as an answer for x. Okay, I mentioned earlier you may not have a calculator that can do that in one shot, so maybe you need a line like this: 64 plus 121, okay, minus 2 times 8 times 11, 2 times 8 times 11, 176 cos 35 degrees. Again, you can do the formula and then jump right to here if your calculator allows it. But if it doesn't, you have to work these out in pieces. Go for it. Whatever works best for you, whatever you're more efficient at. Okay? So we can just check that this checks out, just to prove it to you. 64 plus 121 minus 176 cos 35. And you have to get the same answer, and I do. Okay? And then you would square root that, and you get 6.4 units. Okay, R2, get into low power mode. Example 3, rebels. So here we go. Triangle ABC. We don't know side x. You could also think of it as side A. And we have no corresponding pairs. Okay, as I mentioned, corresponding pairs lack when you need cosine law, and no 90-degree triangles. So here's the approach. If you can remember the pattern for cosine law, you want to find this side. You have his angle, and you see he's sort of sandwiched by two known sides. Okay, so I'll write the formula out this time. The one that I say you need to memorize. We want to find a, b squared plus c squared. Okay, notice it's different than a, minus 2bc cos a. You don't really need to write that though. If you know your stuff, you do the following, okay? So we want to find side x, x squared, okay? Then you know you're going to have angle A over here as 63, because they have to be, those two work together, the side with this corresponding opposite angle, okay? Then, like I mentioned, these two sandwiching sides, you go in order, so 5 squared plus 4 squared. Then you do minus 2 times 5 times 4, minus 2 times 5 times 4, okay? Finally, you can take the cosine of 63 degrees. So you always have this guy out on the end here, and then across from him goes out on this end, and then you sort of put the sandwiching sides, 5 and 4, they have their part in the formula in here. Okay, so that's the pattern, and why don't you pause, try solving that, and check your answer. Okay, you're back, you've tried this, and I worked it out the long way, so there's all my numbers. Okay, and then I ended up taking the cosine of 63 to 4 decimal places, added those two numbers up to give 41. Okay, next up I'll have to multiply 40 by 0.4540, and I get minus 18.1596. Take that away from 41, x squared is equal to 22.8404, and x is 4.8. I did it the long way just to show you, like, if you can actually get your calculator to work with one shot, it saves you all this writing, and I recommend you get yourself a calculator like mine that has the screen that lets you enter multiple things at once. Okay, it shows you the history of what you put in your calculator. I find it's really good, so I'll show you with the faster way I prefer you could do if you have the right technology. That's 2 times 5 times 4 times cos 63. Okay, and you could even go back and see if you typed it right, which is really great. And finally hit equal. What do I get? 22.8. Okay, so there's that point there, and essentially the exact same numbers, and then I know I need to square root that, and I get 4.8 when I round that. Okay, example 4 is definitely different. Now we have this triangle where we know all three sides and we want to find angle x. And the only law that ever allows you to do that is the cosine law. Okay, so let's write the cosine law out. Okay, a bit differently, not quite. So this time, usually like we're after a side, and the side we find has to be opposite an angle. Okay, so if we're going to find angle x, we'll still need to know what his opposite side is. And instead of him being unknown at the start, now we know him. So we know 4 squared. And it's sort of like you trade spots. Earlier we didn't know this value, and at the end we knew the angle. Okay, so we don't know the angle now. Okay, and it's like before though, where we didn't know the side and we put the angle here. Now it's just switched. We do know the side, and across from him we don't know his angle. And that's the same idea as before. Look for that sandwiching. You can draw lightly on your triangles like this to help you with that. Okay. All right. So the sandwiching's the same. All right. Like I started on the left and I moved down. So 5 first squared plus 8 squared, and then subtract 2 times 5 times 8 cosine of x. All right. And this time there's only one unknown, and it's x. You'll solve this part here the same as before, and then I'll show you at the very end you'll have to do something a little differently. Okay, so here's what you do. This is 16. Okay, this is not one you can completely put in your calculator, so you got to do it in pieces. 4 squared is 16. Now 5 squared plus 8 squared. Let's just write it out. 25 plus 64 minus 2 times 5 times 8. So 2 times 5 is 10, and 10 times 8 is 80, times the cosine of x. Okay? So here's what happens next. Let's keep 16 here, and 25 plus 64 is 89. And we still can't do anything with 80 times cos x. All right, now you need to get into the mindset of, I need to get the variable on one side and the constants on the other side, and the sides being sides of the equal sign. Okay, so all of this is working with the variable of x. We're going to want to leave it on the one side of the equal sign, and I'm going to do that so it's on the left. So I'm going to send this over, and it becomes 80 cos x, because remember it's minus 80 times cos x. That's one big negative term, and when you send it on the other side of the equal sign, it becomes a positive term. Okay? Alright, so if I send him over, think about what's left here. We had 16 here, and we had 89 on this side. Well, I'm also going to send 16 over here, and it becomes 89 minus 16. Okay? And let's work all this out. So 80 cos x. 89 take away 16 is 73. Alright, so 80 times cos x equals 73. 80 times cos x. Well, I have to undo 80 times cos x by doing a divide by 80. And I also have to do that on this side of the equal sign to balance the equation. Okay? And that cancels this 80. Grab your calculator, and you'll need to know what 73 divided by 80 is. 0.9125. So cos x equals 0.9125. And like we've seen in other lessons, and we've been doing, to get x removed, okay, or to undo the cosine of x, we have to do the inverse cos. All right, and that looks like this when written. X equals cos minus 1, and that means the inverse cos of 0.9125, and your answer is given to you by your calculator. Again, you have to be in degree mode. I know you know that, but just reminding you, always turn that calculator on, make sure it's in degree mode. All right, so I already had the answer. Where did I clear it? All right, so anyhow, shift cos 0.9125, 24 degrees. All right. So one of the common mistakes people make, remember when you send minus 80 cos x over, it becomes positive 80 cos x. Okay, this is an important step where you rearrange so you have a variable on this side equal to only constants or numbers on the other side. Okay, rebels, we're going to have to hurry. One last example here. Trouble's brewing. So draw out this diagram and let's do this. Okay, there was a side missing. Did you catch that? To do cosine law, and you want to find angle V, you would need 3 sides. So if that confused you, shouldn't have really. I mean, think of it as you were thoughtful and realized, I need 3 sides if I want to find angle V. All right. So here's the approach. You want to look for that sort of side that is known and angle that is not. Or you could have angle known and side not being known. And they get set up into the cosine formula as follows. So if you're working with these two as the corresponding pair and the cosine law, you take the side and you square it. At the very end of the formula, who are you taking the cosine of? His corresponding angle. So the cosine of angle V. Okay? Then the other two sides must be known. We've been calling them the sides that sandwich angle V in this case. And it really doesn't matter what order you go. Well, it might as well be consistent. We'll go 12.5, square it, plus 10.3, square it. Then you subtract 2, it's part of the formula, okay, times these same two numbers. So 2 times, I'm going to run out of room here, 12.5, and then times 10.3. Okay? So essentially, the yellow two numbers that are sandwiching 12.5, that yellow, and then 10.3, they go in here in that order. Okay? And your formula's pattern is such that the ends always go like this here. So the 11.4 goes here, and V goes at the end. Okay? Now, pause, solve this, try it one shot with your calculator, and see if you can do it. You won't be able to do much as one shot rather in your calculator, because this is one where you have to do things actually in parts. So sorry about that, but yeah, you have to do this in parts. And here we go. So 129.96 equals 12.5 squared is 156.25. And I'll just keep going here. So check your answers. Okay, all that multiplication, 2 times 12.5 times 10.3 is minus 257.5 cos V. Okay, so looks big, a lot of decimal numbers. Take your time. Okay, next we can add those two together. That's the only new step on this line. So that becomes 262.34 minus 257. Great. Okay. So now is where everything sort of switches sides. I'm going to bring this over here, change his sign, and I'm going to send minus 257.5 times cos v over here and change his sign. And you get the following. 257.5 cos v equals 262.34 minus. Okay, so variable on one side equals the constant numbers on the other side, and we just have to simplify that. Okay, so 262.34, take away 129.96, 132.38. All right, we have to undo 257.5 times cos v. To undo multiplication, you divide. And you have to do it on both sides. We keep the equation balanced. So cancel, cancel. You're left with cos of v. And that equals 0.5141. Grab that calculator of yours. And you do the inverse cos. So this means inverse cosine, inverse cos of 0.5141, and you find out that v equals 59 degrees.